So, as I was telling that mm, uh, this growing concern is actually pervading into big industries, and we try to kind of dig out if there is some signal, there is some early signal. mm, which kind of shows the efforts of the industry, uh, and we curated some uh, mm, query words like fight head. This is one example. We curated many similar query words, and you see when I search Microsoft Bing, it is giving me quite a few relevant suggestions. Similarly, now when I do the same search on Google, it also gives me some pretty relevant suggestions. In fact, when I do it on Twitter, it actually tells me that there are groups like Fight Hate Speech and Anti-Semitism Task Force and things like that, which are actually taking a huge drive forward in reducing online hate speech and trying to make the online world more safe and peaceful. Uh, okay, we did a similar search on Facebook, but to our surprise, we did not find much suggestions. Maybe they are still working. Okay, so like what uh, should one expect from this tutorial? So the question is is the problem really important? Are we really tackling an important issue of the current times, and how deep are the repercussions? It seems that we are not alone. There are many people across the globe who are concerned about this problem, and in fact, United Nations in 2019 set up this strategy and plan of action of hate speech, where the Secretary General notes that this is one of the most disturbing problems of current times, including xenophobia, racism, intolerance, anti-Semitism, anti-Muslim persecution of Christians, and things like that. So this is a growing problem, and he actually observes that due to this pressing issue, he has commissioned a set of senior advisors who were tasked to design this strategy and plan of action for hate speech. And what they came up with are the following. So these are the 5 key points that they felt, that the senior advisors felt would be the most pertinent ones to look into. So one is the monitoring and analyzing of hate speech, addressing the root causes, drivers, and actors of hate speech, how to use technology, and using education as a tool, making awareness programs, and then deploying mechanisms for countering hate speech, like generating counter narratives to dilute the vicious effect of hate speech. So these were some of the points that were raised in that meeting, and they were set up into a strategy plan. So our tutorial is actually organized or aligned along these strategy plans. So the first part of the tutorial will talk about the first key commitment, which is monitoring and analyzing of hate speech. So basically, in this part, we question how does hate speech spread in the online world? What is the depth and the speed at which these elements spread in an online social network, and are there computational approaches which can help us to estimate the speed or estimate this depth, and what are the long lasting effects of such a spread if it is left unmoderated. So the second part of the tutorial is trying to use technology and trying to use technology in a meaningful way in order to find the root causes. So what some of the industries or how some of the social media platforms are coming up with is an auto flagging system. So where if a post is like classified by one of their algorithms as hateful, then they would either auto flag it or even auto discard it. Now, these detection algorithms have their own caveats. They have their own misclassification rates, and therefore that has its own repercussions on freedom of speech. Therefore, there have been efforts to also develop advanced detection models or advanced detection algorithms, which also have an explainability component with it. Like if you are auto discarding something, like can you explain why you are auto discarding, or if you're flagging something as hateful, can you explain why you are flagging it as hateful? And then there are, of course, biases in the evaluation, biases in the construction of the training data, and these biases actually perpetuate into the uh, model and and also affect the misclassification rates. So these are some of the things that we are going to discuss in more depth in the second part of the tutorial. In the third part, we will talk mostly about the mitigation strategies, like how does one make efforts, consolidated efforts to contain online hate speech. So, and does this containment in some way conflict with the freedom of speech? For instance, like are there ways in which we can use the modern day LLMs to automatically generate counter speech? So uh, typically the procedure has been so far to craft counter speech manually using NGO operators or like internally in-house uh, workers for certain social media platforms. But then with the growth or the proliferation in the number of hate speech posts, the volume is like tremendous to be controlled using just manually crafted counter speech. So the idea is like whether one could use the modern day generation techniques in order to generate counter speech which are meaningful, which actually do the due diligence and resolve the purpose and solve the purpose for which they are constructed. So that is what we are going to talk about in the third part of the tutorial. So in addition, we would like to present a SWOT analysis, which would tell the young people, mostly like people who are students in the audience or people who have just started doing research in this area, about the different scopes and the different problems, the issues that one faces. And some of these issues actually can be very well formulated into newer problems. And in addition, we are going to introduce to some of the resources that we have built, like a Notion page, which like curates from time to time all the different papers, the different data sets, and the different codes that are relevant to this area of research. And then depending on how much time we have, we also plan to do some hands-on. So the negative consequences of hate speech is not restricted to the online world only. In many cases, we have seen examples where the online negativities actually permeate into the offline world, into the real world. And some of the examples of such transcendences are like noted here, with the recent one being the Delhi riots during the CAB NRC issue. So there have been some related tutorials in this area. One was in CIKM 2020, and the other was in ICWSM 2018. But none of these were organized in the way we have tried to organize it in the framework of the UN strategy plan. So that is one of the key points, like where we differ from these previous tutorials, and we hope that would enable the audience to have a better view of the overall research perspective in this area. So the table of contents is like as follows. So we will start with some preliminary definitions and related concepts. Then we will talk about the analysis of hate speech, specifically its prevalence in the online world. Then we will talk about detection in details, like the different data sets available, the models that are present, the different biases that appear in the annotated data, and what kind of explanations one can provide associated with this detection outcomes. And then in the final part, we will talk about the mitigation approaches. We will talk about like the effects of banning people like hurling hateful comments on the social media, whether banning or suspension actually help, and if it doesn't, like to what extent counter speech could take its place or replace it, and like what are the methods by which one can generate counter speech effectively, and what and are there really like deeper effects of using counter speech. So, for instance, whether the purpose for which counter speech is generated is really served or not. And then, as I said, like we will end with a SWOT analysis. So, but to move further, we need a working definition of hate speech. So, basically, throughout the tutorial, we will assume that hate speech is a sort of a direct and serious attack to any of the protected category of people. And this protection could be based on their race, ethnicity, national origin, religion, sex, gender, sexual orientation, disability, or disease. Now, typically, there are two types of hate or hateful comments. One is called the directed hate, where the hate language is targeted toward an individual, towards a specific person or an entity. Whereas the other form is the generalized hate, where the hate is towards a general group of individuals or a community. So I have noted down examples of each of these. Typically, when we will be talking about hate in the following slides, we would refer to generalized hate unless otherwise mentioned. So, Fortuna et al. In 2018 actually came up with this beautiful taxonomy, like of harmful content online. So they divided it into various subparts, various fine-grained subparts, like hate, cyberbullying, discrimination, flaming, profanity, abusive language, toxic language or comment, extremism, radicalization. So each of these are like, if you see, the boundaries are not very distinct, but then like they have certain individual differences. And in this tutorial, we will be talking mostly about the first, hate, which is expression of hostility without any stated explanation, and abusive language, which is like referred to any hurtful language that includes hate speech or derogatory comments. So these are the two things that like will recur mostly in the tutorial. So now hate speech could appear in different contexts, like it could be that the targets of hate speech, or the victims, as we say, of hate speech, actually depends on various different things. It is uh, like sometimes dependent on the platform, it is sometimes dependent on the demography, sometimes on the language, sometimes on the socio-cultural landscape of people. So there has been focused research on some of the targets, like some of the specific targets, like people have taken up and done extensive research on them. One among them is racism, studying hateful comments against blacks on Twitter. This was a pretty early work. Then studying misogyny in Reddit, in this was a work in 2019, published in 2019. We also had done some similar work, similar follow-up work. Then xenophobic behavior during COVID-19. This work was published recently in 2021. In fact, there have been various follow-up works after this also. And now, sometimes what is interesting is that they often become parts of different communities, or they spearhead these hateful comments, actually spearhead the activities of different communities. For instance, there is this genetic testing conversations. Like, this work was published in 2020, where uh, people were found from the alt-right groups to take interest in genetic testing, and they were trying to attack minorities and prove their genetic impurity. So basically, hundreds of millions of dollars were being invested by these groups in order to establish the purity of genes, and thereby attack certain minority communities. The other one, which I guess is very popular these days, there has been a lot of work, a lot of research work that has gone into this area, which is QAnon conversations. And here, this was the politically incorrect board of 4chan, from where the whole conversation started. There was a person with the nickname Q who posted numerous threads claiming that certain US government and officials, Democrats, celebrities were related to um, unhealthy crime, and then also tried to establish that how Trump has been spearheading to stop this movement. And this has been sometimes connoted as super conspiracy theory. So this kind of gives you a rough idea of the importance of the problem, as well as why one should take forward and uh, like have um, a, a full-fledged research agenda on this area. And I hope the next parts of the tutorial will give you even further in-depth understanding of the impact of the problem, and the robustness and the strength of the solutions and of the current state of the art. So at this point, I'm going to leave the stage for Purnojoy and Mithun, who can carry forward the next part of the tutorial. Thank you very much.
Okay, so let us move on to the next part, that is the analysis and spread of hate speech. Here we'll be mostly talking about the prevalence as well as its effect. Yeah, so before talking about prevalence, we'll need to find platforms where you can study hate speech. So now there are broadly two categories of platforms. One is the Gab, 4chan, or BitChute, like moderation-free platforms where there is no moderation. And the second one is moderation enabled platforms like Twitter or Instagram, YouTube. So both these platforms are more or less equally studied in this context. Yeah. So the first platform that we're going to study is Gab. So Gab is an open moderation-free platform, which is similar looking to the Twitter platform. And it was launched because of the moderation, the presence of moderation in Twitter. So there has been a lot of studies in Gab which tries to understand the presence and prevalence of hate speech. And in this work, they actually tried to understand the hashtags present in Gab. And as you can see, the ones marked in red are actually two of the hashtags which are like alt-right and ban Islam, which shows that Gab already had early signs of hate speech. This data is from August 2016 to January 2018, which shows that even and Gab was started around that time only, like August 2016. So even with the starting of Gab, it already had some signs that it was growing to become a hatred spreading platform. In this work, they mostly used some frequency-based method to calculate the hashtags and then normalized it. In later work, there has been further efforts to understand what the hateful users are doing in this platform. And one interesting study actually did some hateful user extraction. This was done using the similar method that I talked earlier. Like they had some lexicons which are mostly about hating different communities. These are already, you can find them in the hate-based dictionary, or if you search online, you can see this kind of slur or derogatory terms. These were used to calculate, get the keywords or lexicon, and from there they created they extracted the hateful users. And these hateful users were then again put on the repost network. And the repost network is how you someone is reposting or retweeting one's post, and then they apply a diffusion method to on this repost network to get the more broader range of users. So we have some users who are already known as hateful, and from there we try to diffuse their belief system to the other users in the network, and then select the ones who are highly hateful. So here they used a belief score of 0.75 to 1 to select the hateful users, and 0 to 0.25 to select the non-hateful users. They found that the post of hateful users diffuse significantly farther, wider and deeper and faster than the non-hateful users, as you can see in the graphs in the right side. Another study which was on the same line tried to study the core network characteristics of the hateful users in Gab. In this user, they also used in this study they also used a similar strategy, like they extracted the hateful users first, and then they used a temporal K-core analysis. If you are familiar with network analysis, you can you know a bit about this K-core analysis, which is trying to create different cores to select the users. And in this K-core analysis, they finally created some buckets, so like 10 buckets, and then they try to see how the users are moving in these buckets. So here they saw that the fraction of hateful users in inner core actually increased through time in Gab. If you see the graph in the right, they have ranged from October 2016 to June 2018. And as you can see, during after August 2017, there is a huge jump in the users, the fraction of users, like hateful versus non-hateful, and it has actually crossed 1. That means the amount of hateful users are actually more than the non-hateful users. And this ratio has again like stabled in the later months, which is quite prominent. So this means that the hateful users are actually taking the inner core more than the non-hateful users. So there has been in other platforms also, like 4chan. 4chan is again a platform similar to Instagram where you can share photos and also comment on them. And this work actually shows the post or amount content in the political thread of 4chan. So what they saw is that there is 27% posts which are severely toxic. They measured this using the Perspective API, which is a common API to detect toxicity. And this has the following categories. And through the CDF analysis, they try to understand what are the different categories of toxic language present in the here. And they find that severe toxic has a larger presence, and which is pretty concerning. So now when we have like more or less covered the platform without moderations, there has been similar studies on platform with moderations as well. But in this study, they try to do the same, that they select some of the hateful users and then try to see if they can do the analysis on these users. So one particular difficulty is that due to the moderation, the creation date of users were highly hateful. That is shown using this red plot. You can see that their creation dates is very near to the end date. That means they are recently created. Why is this point? Because since they are highly hateful, they get moderated often, and so they need to create new accounts every now and then. Their second finding was that hateful users are power users. That means that they post more number of posts per day, they favorite more, like they favorite more posts per day, and they also follow more. So these are the characteristics of hateful users which can make them power users. Another fact that they found was the median hateful user is again more central to the network. This is similar to the findings that the earlier paper found on the Keiko analysis. Here also, even with their constant moderation, they are still able to get to the center of the network and influence a lot of users. Okay. Now, once you have understood that hate speech is pretty prevalent on moderation free as well as moderated platforms, we'd also want to see what is the effect of hate speech. So as we have already talked about in the introduction, that the effects of hate speech can be various from offline to online events. So one particular thing that is very important is the psychological effect of hate speech. Like what happens if you read something of a hatred, if you are from a victim community or normal people, what happens? So these studies have been done pre-social media. So at that time, there was no such like online content present, but still people had to face some hatred from some person in offline event as well. So they had an interview-based study which revealed that the effect of hate speech in short term, that is just after the event has took place, is emotional, and in the long term, it is attitudinal. And two of the most common speculated motives behind hate speech was ignorance and repressed hostility from the speaker. And finally, the most important part here is that most participants prefer passive response. That is, they do not want to engage with the speaker. This part actually is not that relevant now because of the online world. And we have, if we prefer this sort of passive response, even then the hatred or the hate speech in the current world is constantly increasing. So we need more active response in like without this passive response. Another effect of hate speech can be on the young people. So in this study, what they found is how the prevalence of hate speech is present in subreddits of college. So they saw that there is significant difference between the hate exposed and non-hate exposed groups stress level. So they took different subreddits of different college groups And then there they had some groups which were already exposed with different hate, and others group which were not exposed. And now they used a stress detector that can be a simple lexicon detector or a classification model, which can detect the stress through some text based output. And in this study, they saw that okay, this stress level is different for the groups exposed with hate versus the group exposed with non-hate. Till now, we have seen what is the psychological effect of hate speech. There has been other studies which try to understand what is the effect of online events on hate speech. So the offline events on hate speech. So this can be hate crimes or terrorist attacks. So in the first study, they tried to understand through an interview that what is happening if they looked into the pathways of effect and response in the study of impact of hate crimes. And one of the interesting findings was that direct victims who are directly affected by hate, or they have faced some hatred event in their past, they actually are becoming less empathetic towards other victims. And another finding was that whatever they saw in the initial behavioral intentions, for example, one behavioral intention can be that they will make other people more aware about it. But this does not actually transform to actual actions. So the behavioral intention can be, I want to make you aware about this hatred, or that you should not be hateful, but it does not actually transfer to actual awareness. So the user does not take the action. There has been another large scale study which tries to see the effect of hate crime and terrorism on hate and counter speech. Two of their major findings was that the terms with violence and offense increased after terrorism, but not after hate speech. So you can see this using the blue and the pink bars. So the pink bar actually represent the ones after terrorism, and the blue ones represent after hate crime. So you can see that the pink bars are actually higher. And this shows that after a terrorism event, the hate content about the target community is actually increasing. Similarly, but one good side of this is that the terms with counter speech is also increasing after the terrorism and not after hate crime. So both the hateful as well as counter speech is increasing after an terrorist attack. This might be due to the generalistic nature of a terrorist attack, because a lot of people come to know about that. And for hate crime, it may be a localized response. So this might be one of the reasons. So till now we have talked about what is the prevalence of hate speech and its effect on psychologically, what is the effect of them, and finally what is the effect of other events on hate speech. But there are other forms of like related terms which is not hate speech directly, but it is very related to that. So for example, if you see this the post here, the second example is actually hate speech because it directly says that the person is a hating Muslim. And the last example is not something hateful. It is just an opinion. But if you see the first example, it has several parts. Like first part is trying to create some misinformation. Then there is a fact. Then they want to take actions against the Muslim community. So this kind of message. So again, this message is just like a very concise version of the whole message. This was actually very large. And we term this message as fear speech. So it contains elements from history, in misinformation, and vilify Muslims, and to the end that they ask the users to share the post in a very subtle way. So one of the interesting parts of this language is that it is very non-toxic in nature. So usually with hate, we see that most of them can be easily identified by some lexicons. But for this message particularly, if you see carefully, there is not much of a toxic language or toxic keywords present in them. This actually drops down their toxicity value. If you see hate speech and fear speech, there is a lot of gap in their toxicity value. And actually, fear speech is quite close to the normal speech. Now, this study is done using the Perspective API, which is mostly like tested on detecting toxic language. So what do we do about fear speech? So again, we can try to build a classifier which can detect fear speech in the wild. So there has been two works broadly. One is in WhatsApp. That is, they are trying to collect data from WhatsApp, and then they um, do the annotations using some in-house annotators. And finally, they reach a data set around 5,000 total posts with around 1,142 fear speech. The second study is on Gap with MTurk annotators. They reach around 1,800 posts. This data set also has hate speech with that. So it helps in identifying the differences between fear speech and hate speech if they are both present in a platform. Finally, we can use something like a BERT or a Roberta model to detect fear speech, as we will see in the detection pipeline. So that can be done. But what are the main findings from fear speech versus hate speech comparison? So we observe that the average level of engagement of users with fear speech post is much higher than the hate speech post. This is evident from the red bar that you can see here in these slides. You can see that the red bars is quite high than the hate speech and the normal speech as well. This shows that it gets more replies, first of all, then more reposts, and finally more likes than the hate speech. Another effect is on the normal users. So what are the normal users doing to this fear speech or hate messages? They again see that the fear speech is actually having more number of normal mentions. So they are mentioning the normal users in their post to include them in the conversation. Normal repliers are more here. So they are more number of normal people are actually replying to the fear speech than hate speech. And finally, they're the normal reposters, that are people who are normal and they're reposting the fear speech. That is also more than the hate speech. So overall, this hate speech, the fear speech phenomenon is actually more subtle in its nature and more like penetrating into this normal users part. So we also tried to study the same thing in the wild, that is on Twitter and Facebook platform. So we had already built a model for detecting this this content. So we applied the same model to these two platforms, that is Twitter and Facebook. So for Facebook, we use the CrowdTangle API. And for Twitter, we already had access to the Twitter API. And here also we see that this phenomena of fear speech is present in these two platforms as well, quite significantly. So for fear speech, if you look closer to 2021, it has reached around 20% of the total collected post. And for Facebook, it reaches around 10%. So again, it has a significant amount in these platforms as well. And it is a very important field to start looking at. So as we see, not only hate speech, but also different forms of other content is also highlighted in this online world. Hence, we would like to point you towards creating an umbrella of such content. And we can call this as harmful speech. So it will include a range of phenomena that often overlaps and intersect, and includes a variety of types of speech that cause different harms. This can include hate speech, fear speech, cyberbullying, trolling, offensive speech, and call for violence. And each one of them, we need to actually understand first their prevalence, and then finally try to detect and mitigate them. And all of these terms will require their own mitigation strategy, because none of them are similar to one another. Yeah. So now we will be talking about detection of hate speech, which will be taken up by Mithun Das.
So hello everyone. So the analysis that have been discussed so far, what happened, like the majority of the time, the hate speech has been detected with some lexicons, basically, like people created some hateful lexicons, and they checked if those hateful lexicons are present in the post or not. If that lexicons are present, they consider that post or text as hate speech. But however, this is not the case always. It may happen that someone can use some hateful token to respond to a hate speech, and therefore the distribution that people are getting or got earlier based on this keyword set, that may not be always correct. So presence of a particular keyword does not mean okay that post is hateful. So therefore we need better detection system, like how we can accurately detect hate speech on social media platform. Okay, so generally these detection part to detect this hate speech, people are developing model. However, as we know, like for the supervised model, we cannot just use unsupervised data sets to detect hate speech or even any other kind of task similar to hate speech. Therefore, we first need to create data sets, and that can be used for the purpose of building model. So like the data sets that have been created by the research community, so that is not unimodal. So basically data sets are unimodal and multimodal, although like most of the research that has been happened earlier was based on this unimodal content. So I will just explain what do I mean by this unimodal or multimodal thing. So in the case of unimodal content, basically when I am making a post, maybe I am just writing some text on social media platform, only the text has been posted on social media and nothing else have been used. So these kind of content where only like one form of content I am posting, that is called unimodal. In the case of multimodal, maybe it is not that I am just only posting text. Maybe for example, we can take memes. So basically what happened in memes, there are mainly two components. One is that image part and one is the text part that is embedded or associated with that image. Combining both image and text, maybe like people create memes, and those things also can be posted on social media. And these are called multimodal contents. People also can post videos also in social media, and hate speech can be propagated by all these kind of form, whether unimodal or multimodal. So these are the major dimensions of data sets and people are working on. So further, the data sets that have been developed, like different research community or different researchers follow different taxonomies. It is not like always same for all the researchers. For example, there is this binary classification where people may try to just detect whether a particular post is hateful or not. Then there are this targeting group kind of hate speech where just people try to find out what is the target of that hate speech maybe. Then there is this specific binary kind of classification where people are interested more about, like, for example, this misogyny hate. Here, basically, they try to find out, okay, whether this is targeting like women or not. Then there is racism related hate speech. So these are the kind of classification tasks people are trying to do. Further, people are developing data sets that can, that is multi-level or multi-class data sets. So they just not only detect whether this is hate speech or not, they basically further subdivided it to several categories. For example, this hate speech, offensive speech, profanity, etc. So these are the various kind of data sets so far have been developed in the research community. So now if we look into the sources, like from where people are collecting the data sets, so these are the sources that have been that we have showed in this figure. So thanks to this paper, direction in abusive language training data systematic review, we got this plot from there. So you can read that paper also in detail later. Yeah. So now if we see the platforms that have been from where most of the time the data have been collected, that is Twitter, you can see, because the reason is it was very much easy to get access to Twitter and Twitter API. And by using those things, basically people used to crawl data from Twitter. Although now it is not free, it is paid, the collection of data from Twitter also. Apart from that, we can see, okay, well, some studies have been done on several other platforms. However, it is not always easy to do those study on those platforms. For example, this voter parlor, because these are the alt-right platform, and sometimes they call them free speech, and people post anything there, and sometimes these platforms even have been taken down because and due to that reason, most of the time studies are limited on this kind of platform. Also, in terms of data sets that have been developed so far, the data set by Davidson and Fonta, these two data sets have been highly used in the research community so far. You guys can use those data sets if you think, okay, you are interested. Okay, so further in terms of the languages, basically, so in social media, it is not always the case, okay, people will write everything in English. So there are this multilingual content. They are like individual have their own choice in which language he want to post. However, if we see the majority of the researches that have been happened so far were mostly on the English language, although now people have focused on the multilingual sites also. There are data sets coming on other languages. Even we can see for the Arabic, Italian, Spanish language and Indonesian, there have been more than 3 data sets. However, like even although like we have multiple data sets coming and on multilingual sites also, still it is questionable, like how is the quality of these data sets. Also, the another thing is, as we can see, there are a lot of data sets that have been already published in the English language. Can the data sets on English language benefit to detect hate speech on other low resource languages? So further, if we see the sizes of the data sets, so we can see the most of the time the data set size varies in the range of 5,000 to 50,000. And if we see the amount of head content that is present in the label data set, so that is in the range of 25% to 50%. Okay. So far we have discussed the kind of the different kind of data sets or maybe different types of data sets that have been developed. Now we'll move forward with the detection mechanism, and because with that now we have the data set study. So like earlier to detect the hate speech, the features that have been used, so that were pretty much simple. For example, Davidson earlier used this TF-IDF vector, then this part of speech tags, and then several linguistic features such as semantic lexicons, like frequency count, readability score, etc. So nowadays also we can use these features to create our baselines model. Further, with this deep learning era, like this, when this word embedding and sentence embedding came, people also like represented like textual data with this embedding to classify whether a post is hateful or not. So in terms of detection method, so the earlier basically people were using simple traditional model, for example, the logistic regression, support vector machine, and is XGBoost kind of model. So once the features were extracted, basically they passed those features through the simple model to develop their classification models. However, like with the advancement of deep learning era, then people started using model like LSTM, GRU, CNN, GRU, etc. To have better model so that the performance can be improved for the detection of hate speech. So in a study also, like it has been shown, like when they used the CNN plus GRU model on multiple data sets, basically the experiment has been done and they have seen, okay, the performance have been improved quite well compared to the traditional model like SVM. So like, although like we have seen several deep learning models that have been used earlier for the detection of hate speech, however, it is not the case, okay, those models were very much perfect and were able to detect hate speech in various contexts. Still, those models were having some like limitation. Sometimes they could not capture the context completely. So therefore, like thanks to this recent advancement of this transformer-based model, BERT. So BERT is basically a transformer-based model, like which is generally pre-trained on a large corpora of raw unsupervised data sets. And with after this pre-training, basically now people have their like choice to fine-tune. So this model can be used in various tasks. For our case, like it is hate speech. So basically, we have the BERT model available in the research community. Now, if I want to, I want this model to detect hate speech, so I have to fine tune the model on specific data sets. Let's say with hate speech data sets that we have, so we can fine tune this model. So yeah. So these models have been tried out by several researchers and have seen, okay, so these model are pretty much getting or showing good performance. However, like people still try to improve the performance, like how can they detect head speech better? So along with BERT also, like people are trying to combine the LSTM or CNN model. And they have seen, yeah, after extracting, let's say, BERT feature using those LSTM or CNN models, even gives us better performance, as can be seen from the table. So further, people are trying even other kind of like modeling architecture to detect hate speech. So what they are doing, particularly in this scenario, so there is one Heartlex lexicon. So that is a lexicon of, let's say, hateful keywords. So people are like not only just passing the input text or the data sets through this BERT layer. Apart from that, those corpuses are getting passed through the Heartlex lexicon, and one hot encoding has been like let's have been developed, and then by using this Heartlex encoding and the extracted BERT feature, they are further just passing it through another dense layer to make like better prediction basically. Apart from that, so there have been other work where they are just trying to make the BERT model even better. So what they are doing, they are just retraining the BERT model with band subreddit data, and they named it headBERT basically. Here, the retraining is almost like similar to the pre-training steps that have been followed like while creating the base BERT model. Like instead of just one mask in this scenario, they have this two masks while pre-training, and the model have to predict which tokens will come on those places. And the data sets that have been used, the subreddit data, as can be seen, these have been banned. So the hate percentages that have been present in this data is more, and while retraining the BERT model with this kind of data set, it has been seen, yeah, the model performance even improved, and it has been shown in various data sets. Okay, so so far the detection mechanism that I talked about, like it was mostly on the English language only. However, as I said earlier also, the social media is not only about English language, and there are other languages also. People post in their mother tongues. So research is needed in those kind of low resource languages. So in this research by Aluru, they have basically considered 9 multilingual languages, and the data has been collected from 16 like different sources. After collecting the data sets, they have like tried several experiments to check like which model performs better. For example, in this table, they have shown the low resource performance and high resource performance. So what do we mean by low resource or high resource setting? So let's say in case of low resource setting, I have very limited number of data points, let's say 32 or maybe let's say 64 data points have been labeled. Now, if I want to create models only with those limited number of data points, so how will the model performs? Like which model will be better? So it has been seen when we have very limited number of training data point. Simple models such as laser plus LR have been performed very much well across all the languages. So laser is the laser embedding and LR is the simple logistic regression model. And when we have this high resource like setting, when we have like this more labeled data sets, in that time the table is a bit of mix. It is not like always one model is performing better. Although if we see like the MBERT model or the as in generalized term, the BERT based model, they are actually performing pretty much well compared to the simple like this traditional model like logistic regression. So why this low resource like experiment is needed? The thing is like as we know, when we create or develop data sets, we need annotator who can easily understand the task to label whether a particular text is hate speech or not. But it is not always possible to get or gather annotator who can like understand the task properly and do proper labeling. So because that's why basically even if we can get some people to do some annotation by making them understand what is the task, maybe That's why this low resource setting is important, because even with less data point, we are trying to build at least some model. Okay. Apart from that, as we said earlier also, like as there are most of the time the data sets in English are like the English languages data sets are majorly dominating. So can that English language data set be helpful to detect hate speech in other low resource languages? So in this paper, basically, they tried to do the same experiment, by using English language, they are trying to see on other low resource languages how this is performing. So basically here the author came up with some novel Excel block, which can learn better cross-lingual like representation, and have seen, okay, yeah, this kind of novel architecture is able to learn better cross-lingual transfer, and maybe have given better performance compared to the other simplistic model. You can read in detail the paper to understand the blog. Basically, I will not explain that part. Yeah, so then there is another work where basically this is almost similar to the retraining part that I have explained earlier with the updated band data sets. However, in this case, the training has been mostly done on the multilingual data sets after filtering based on certain keywords, and it has seen, yeah, the multilingual hate speech detection have been also been better by further pre-training the transformer based model. And this has been shown by this purple line with the cross, and they have shown, yeah, this multilingual hate speech detection can be improved by further pre-training this BERT kind of model. Okay, so then there is another line of work or research nowadays have gained attention. For example, like if you just look into this example, now you can see, okay, the characters that have been used to write on social media, these are in English characters. However, if you can read, like, it is not perfect English, or even sometimes it is not at all English, but however the English characters have been used. So these are called like code mixed data or code mixed text. So the definition of code mixed is here, it is not like people will write in his mother tongue or like in English language only. They use a mixture kind of thing while writing. Maybe some portion can be written in English, some portion can be written using just English character, but in a non-English language. So these are called the code mixed text. And yeah, so this is also another line of work that people have started. And in this paper, in this case, the example that I have showed is considering the Urdu example. This is Roman Urdu, basically written using English characters. However, like people are working to detect code mixed hate speech in Hindi, let's say Bengali, Tamil, even in other languages also. In this paper, basically, they have also proposed one modeling architecture. And they have used like the CNN, and they named this as CNN engram. They have used 4 convolutional neural network after extracting the embedding from, let's say, this BERT or XLMR model or other model. They just passed those embedding to this 4 CNN layer to classify this Roman Urdu hate speech. And they have seen, yeah, like this BERT plus CNN model gave them good performance. Another things to observe, like even they have tried with simplistic model also, and these SVM array plus AB setting, which is this the ensembling of simple support vector machine model, then this ADA boost, then this random forest model, that also have given them similar, almost same performance with this BERT plus CNN architecture. Okay, so then there is another kind of task that people are trying to perform. So hate speech is not always that much easy to detect. So by looking into one text, we cannot always judge whether that post is hateful or not, or even if that post is supporting any hateful comment or message or not. Therefore, people are trying to detect these kinds of hate speech. For example, this is the case where, let's say, someone have written something hateful as a post, and and one person just replied to that post. If you just only look into the response to that actual comment, actual post, so the response looks normal. However, if you see the context, like in which context this comment has been made, we can understand, okay, so this comment is supporting the hate speech, so therefore it is not right to support even hate speech also in online platform. And people are trying to develop models so that they can detect this kind of comments also. So like so there is paper. In this paper, what they did, basically they came up with one simplistic model, so where they used this actual post reply and the comments that have been made and passed them through various like transformer based model, for example this embed model, and then they passed it through various dense layer basically. And they have seen, yeah, okay, so given the context, it is given the context, whether the particular reply is hateful or not. So if we use that context, so it is becoming easy to detect such a hateful post. And they and with their proposed model, they have seen, yeah, they are getting better performance. So although very less work have been done on these dimensions also, however, this is one interesting research people can carry forward. Okay, so the detection part that I have talked, like all of them were mainly on the textual detection side. However, as I mentioned earlier, social media platform is not all about text only. People are posting multimodal content. For example, these are some hateful meme that we can see people have shared on social media platform, and it is not right to make such kind of post. And we should have models which can detect these kind of multimodal memes basically. So before proceeding forward with the detection part, maybe I will just tell the few of the data sets that have been made public on the research community. For example, the first data set, MMHS 150K, is the one of the largest data sets that has been crawled from the Twitter. And after that, like there were other data sets, for example, this hateful meme data set. In that data set, there were 10,000 posts, and the data set has been created by Facebook AI. Apart from that, the multilingual datasets are also coming up. For example, this Tamil meme datasets that has around 2,900 memes, which has been created by Suryavanshi. Although like it is not completely like hate speech detection, it is like kind of troll meme classification. Although in their definition, they define troll meme as like the any kind of offensive meme that has been posted and that is targeting any individual or any community. Apart from that, like people are trying to develop like specific trying to detect memes that are targeting any specific community. For example, there is one work they try to detect anti-Semitism in memes. And further, like people are trying like people develop data sets that is, let's say, related to COVID-19. As we know, when this COVID-19 came, like there were like various kind of memes were spreading in social media by saying like who have basically started this COVID-19, and therefore the author created one hard meme data sets related to this COVID-19. So in terms of model, if we see, like people have tried various kind of model ranging from the simple text-based model, image-based model, and multimodal model. Like in case of text-based model, like the traditional embedding like globe embedding, fast text embedding, that have also been used. Apart from that, the transformer models that we have talked about, people have used those kind of transformer model also. Further, like this image-based model, ResNet, VGG19, etc., have also been used for the detection of hate meme. Although these models just only using one modality, only text or feature or text or image. Also, like this various multimodal models also came up. For example, this VLBART, CC, VBART, VisualBART. And it has been seen like, yeah, this when we use this multimodal model that has been already pre-trained with multimodal data sets, they give us better performance compared to the only text only or image only sorting, even simple like concatenation of image text. So there's Okay, so now we'll discuss about some of the shared tasks that has been organized so far in the line of, let's say, hate speech. So these shared tasks specifically have been organized so that people can take participation and can understand and learn about the task, and people can be encouraged to do research in this line. So the first shared task, as you can see, is that AMI 2018. There, the task was to detect misogyny, hate speech. Apart from that these various other shared tasks also came, like this semi-val HASOC shared task. Although if we see the best performing model on those shared tasks were mainly the traditional model. So as this was in the time of 2018 and 19. Then if we see when the shared tasks have been organized again, or maybe new shared task came, the top performing model that they have shifted basically from this traditional simple model. Now these bird based models are always coming in the top. Also, there are other kind of shared tasks also getting organized. The one that I have showed earlier, so there mainly textual content has to be detected. Now people are trying to detect this hate meme or let's say toxic spam in a post. For example, Facebook itself like released 10,000 data points basically, and like released one competition where people can participate and develop their model. And apart from that, this semi-val 2021, there this toxic spam detection model. This task has been like proposed. Here you have to detect for which part of a particular text is basically toxic. And yeah, so these are the some of the interesting shared tasks that has been organized, and I will recommend you guys. Yeah, you guys can check this shared task, and also it will come again. Also, you guys can also participate here. Yeah, so now so far, like we have seen so much data sets and this so much like a model of what the people are doing. Now if someone wants to start from where I can start my research. So this is a great website. You guys can check this hatespeechdata.com. There they have categorized the data sets in language wise. Like for English language, you will see the list of data sets that have already been made public in the research community. Then you can see other multilingual data sets also, even these meme data sets also they have listed down there. So I will recommend you guys to check this. Just one second. Okay, so although I see the timing is 2:52, so yeah, so next part of this tutorial will start like after the break. So I'll just briefly explain you what we'll discuss. Like so far we have seen, okay, people have developed model, but however we have not discussed, okay, how these models works. It is it the case, okay, we have developed model, we are done with that? But it is not the case. We can see like still there are some limitation present in the model that has been developed. We will be discussing about those things and how we can mitigate those issues that has been present in the model after the break. Thank you. Yeah, so far we have talk about the different data sets that have been presented in the research community, then the different models that have been developed so far. Now we'll talk about the drawbacks that are still present in the model and how people are trying to solve this problem. For example, like in this paper, they tried to show like how there were some wrong evaluation that has been done earlier while developing the model, and because of that, earlier the performance have been seen very much high. However, although that was not the case. For example, the kind of wrong evaluation that has been done was oversampling before doing train test split. So basically, earlier what they did before making the classification, before doing this train test split, basically they did oversampling of the data sets, and due to that there were commonality, like some data points were present in both train set as well as in test set. And as we know, as same data point has been used for training, and when it came during test time, obviously it was got predicted by the model correctly. Also, another mishap that happened was this feature extraction. So here what they did, the author detected the feature using the whole train and test split. However, in real scenario or real life, it is not the case. Like you will not get the test split earlier. So only you should use the train data set to extract your feature. Then the same steps has to be followed only on the test split. So when these errors have been rectified, it has been seen there was huge performance drop. So earlier it has been shown the macro F1 score that the author got was 93.1. However, when this wrong evaluation have been made correct, they seen there was drop in 20% macro F1 score. So it became 73. So from that we can understand like it is not always that much easy to detect hate speech by developing data sets or model, and proper evaluation is needed so that proper evaluation is needed, and it is not the case we should always try to achieve only high macro F1 score or high accuracy. We should try to check if my model is working properly or not, if I have made the proper train test speed or proper steps I have taken or not before creating this model. Also, another observation that has been made was this user overlap between the train test set. So what happened when I write something on social media platform, my writing characteristics may be different from other users. However, the post I am making, there might have been some pattern, like the way I write, maybe there are some pattern present in my all of this post. So it has been seen when there were user overlap between train and test set, instead of learning the actual task, the model may learn these characteristics based on the text that has been passed through this model while training. And when this user overlap has been removed between train and test set, then also we have seen significant drop in performance prior to, when the training was done. Like we see significant drop in performance compared to when there were similarity between train and test set in terms of user. So apart from that, the model that have been developed so far, it's not been always deployed in a real life scenario, maybe let's say in any platform. So people are developing model and they are reporting, okay, they have achieved this much of performance or accuracy with their train test speed that they have made after creating the data sets. However, still we do not know, like, is this model really perfect, or is it able to detect hate speech in all aspects? So in this paper by Roger, they tried to detect weaknesses of various model by creating several functionalities. So in total, they have created 29 functionality. So I will briefly explain what is functionality. Functionality, like in software engineering, it's tries to check like how many functions a software can perform properly that has been developed. And in our case, let's see the model that we have developed, how accurately it can classify different hate speech. Now, these different types of hate speech has been represented as different functionality. For here in the example, we have only shown like two functionality 18 or 19, let's say. There are other functionalities also that they have developed. You can read that paper for a whole list of functionality. Specifically, we will just discuss about these two functionality, what they have seen. So in terms of functionality, like there is this kind of functionality, this F18 neutral statement using protected group identifier. So in that functionality, they have written multiple test cases by creating templates. These are the example, like we are a group of some identity may be any target community, for example, like women, then African American people, then white people. And then there are other kind of functionality, this positive statement using protected group identifier, and these are some examples. So for other functionality also, they have written these kind of examples. These are non-hateful examples. They have written hateful examples also. Then what they did, they passed these examples via some models they have checked. So they tried with three different models. One is this Distilbert model that is fine-tuned on this Davidson dataset. Another one is this Distilbert model fine-tuned on this Fonter dataset. And then this prospective API. So although we do not know the mechanism, like how internally prospective API works, which data they have used for training, although it has been quite popularly used in the research. So that's why they tried this three model. And they have seen, let's say for functionality 18, the performance of this prospective API is very much good, like it achieved 84.1%. Whereas on the other hand, for functionality F19, the accuracy of DBD, means Distilbert model fine-tuned on Davidson dataset, that is performing quite well. On the other hand, prospective API is not working that much well. So it's can tell us like, okay, all model is not perfect, and it cannot, maybe all models cannot detect hate speech in various settings. Maybe some model can detect some kind of hate speech, other model can find can detect other types of hate speech. So these are the limitation that has been seen in the models that have developed so far. And yeah, people are working on that, how we can make this model robust so that it can detect hate speech in all aspects. So the way the testing has been done earlier, it considered the model as black box, and it does not consider like how the model classified that post as hateful or non-hateful. So therefore, another interesting research that people have started, that is explainability. It is not only limited to this hate speech domain only, in other domain also, like people are focusing on this. So in the case of explainability, what happened? So here, when I let's say pass this example text through our hate speech detection system, it has been labeled that as hate speech. Yeah. So, however, we do not know why or where the model has focused basically to detect this as hate speech. Maybe some derogatory words are present, because of that maybe the model has detected that this particular post as hate speech. However, it is actually not spreading any hate speech. It is countering the actual hate speech. So therefore, we need mechanism to understand, or we need mechanism so that model can learn why one post should be considered as hate speech, and then this explainability comes into the picture. Yeah. So explainability can be done in two ways. One is this rationale based, another one is this free text. So in the case of free text, it is basically there is some expert annotator. He basically tries to justify why this has been labeled or rated as hate speech. In the case of rationale, basically why a text has been flagged as hate speech, which are the tokens that because of that the model has predicted that as hate speech. Those things are being marked. I will explain this part in detail. So the hate explain dataset was developed in 2020 and got published in AAAI. So they are basically what they did, instead of just labeling data point as hate speech and on hate speech, they also told the annotator also mark why you feel okay, this should be considered as hate speech. And they marked for this example, they marked okay, because of this presence of this word, the annotator thinks okay, this is hate speech. And what they have seen, when the model has been trained in such a way, this rationalness has also been passed via this model to make the model understand, okay, so this is the reason why annotator has labeled this as hate speech. Then they have seen the model's performance improved. So we can see this rationale helps the model to understand better why a text should be labeled as hate speech. Okay. Apart from that, there were other kind of tasks people are trying to do to improve the model performance. So particularly in this work done by Wittgen, and the paper got published in ACL, they basically first curated a lot of English languages datasets that are present in the research community. And by combining all the datasets, they create one single model. And then they hire annotators and tell them to fool the model basically. So the model, for fooling the model means, so let's say you will be writing some non-hateful text, but the model should predict that as hate. So you have fooled the model properly. Similarly, the vice versa. And what they have done with the basic model that they have developed by combining all the English language data sets, in the first round, with the annotators were able to fool the model 54.7% of the time in total. Out of that, for non-hate post, it was 64.6%, and this is for the hate percentage. So what they did, then they took the data point that was actually took those examples, for example, I wrote something as hateful, but model predicted non-hate. So these examples they have taken and further fine-tuned that existing model. And then again, they told the annotator, okay, now try to fool that model again. So then the annotator again wrote examples and tried to fool the model. So in batch-wise, basically, they crawled or collected the synthetic data sets that has been written by the annotator and further fine-tuned the model. And they have seen with each round of this annotation or each round of this synthetic data creation and fooling the model, when they further fine-tune the model, so it was becoming harder for the annotator also, like to fool the model. Like after round 4, they see in only 27.7% of the time they were actually able to fool the model. So model was becoming more robust with this synthetic data point coming in. And also the functionality that I have talked about, this 29 functionality that has been written earlier, they experimented their model's performance on those functionality also. Even they have seen, okay, like with each batch of data come, the performance actually was improving on that head check functionality. So therefore, the recommended strategy would be not just only rely on the data that we get or get from social media platform, because it may happen, we may not, because sometimes the data set is collected in such a way based on certain keywords, we just call data points. So we may miss certain kind of hate speech, and because of that, maybe the model may not be that much robust. So we should try to introduce synthetic data point if needed. Let's say if in my data set for a specific target community list data points are present, in that case, maybe we can try to generate synthetic data points so that overall our data set is well distributed across different target community that I have considered. Now, another tool that has been developed, this Recast, basically, their focus was mainly, I'm a user, I'm writing something on social media platform. Let's say the internal tool or model that that platform is using flagged my post as hateful. But however, maybe I was not aware like why this has been posted as hateful, or this has been marked as hateful. Maybe I just unintentionally wrote something, but maybe that post contains certain words or certain things, but that has been marked by the model as hateful. So what they did in this tool, they try to show you the visualization of the tokens, maybe like why the model has been detected at the post as hateful. Maybe then someone can just try to like use synonyms for the words that they have used earlier. Maybe can reformulate the post he actually wants to make his post more clean, to make the toxicity less in the text he wants or she wants to post. However, the drawback that is like if malicious users might game the system, they just will try to use synonyms in such a way so that the toxicity score reduces, but still like they are making intentionally hateful post in social media. So now another direction of work that is being done or got popularity in the research community is this bias in datasets or model. So as we know, like bias is not, we don't want our dataset we don't want our created dataset to be biased. Also, we further don't want that bias should be propagated to the model. But however, it has been seen like bias can be induced in the datasets from different directions. For example, how is the data selected? Then who are the annotator of the data sets in the dataset creation process? Then who is the speaker or target? So these are the things like can introduce a bias in the datasets that people are creating. And it has been seen like this hate speech detection system that has been developed. Sometimes it's carry bias related to maybe some identity words, maybe some presence of some identity words is very high, maybe in the hateful post. Maybe those kind of things model can learn, and maybe model can be biased towards certain keywords. So like it has been seen like the annotator, most of the time people try to develop a large amount of or large volumes of label data point. Because of that, they hire annotator. Maybe we are doing crowdsourcing in different platform. Now, when we do crowdsourcing, although we provide them the guidelines, okay, this is what you have to follow, but however, still it may possible he may not fully understand the guidelines and may mislabel some of the data points. And because of that, maybe our datasets quality may decrease a bit. And in this experiment, they have found instead of doing this instead of using the amateur annotators, when they use expert annotator to create their datasets, the model performance have improved. So yeah, from that also we can understand, yeah, we should always try to make the annotator learn the task better, because they play a crucial role actually while creating datasets. Also, like it has been seen the annotators, their age, gender, or then education background, all those things also vary like while creating data sets, and it has been seen, okay, like maybe based on maybe because hate speech is subjective, and maybe some text may be considered as hateful to me, but you may not think, okay, that is hateful. Maybe you have your own reason, and because of that, sometimes this labeling become different from annotator to annotator. Also, it has been seen, okay, so there is a gap, there is a bias basically introduced because of these like different variations uh, of annotator, and maybe lack of understanding of the task, and that has been shown by this plot, like the red point and this blue point, and where x-axis represent the specificity and y-axis represent the sensitivity. So therefore these things also needs to be considered carefully while creating bias, so that based on age or education, we should not just introduce bias in the model or data sets that we are creating. Uh, Further, it has been also seen, like sometimes the data set is created in such a way, uh, like some certain communities tweets or posts may be considered as hateful by the model. So the case is, it is not the case. Like every community or maybe every people has its own unique characteristics, and maybe he speaks or write in that way, but the tweets or post that is coming from one particular community, and because they speak or write in a different fashion or manner, it should not be considered as hate speech, because it is their choice how they want to write, as long as they are not actually truly hateful speech. But however, it has been seen, like there have been data sets that have been created, and when they tried, okay, like how different communities text have been detected as hateful and non-hateful by this model. So it has been seen this African American aligned tweets have been mostly detected or considered as hate speech by the system with respect to this white aligned tweet, and the value here greater than 1 indicating, okay, the data sets is biased, which has been used to develop the model. And almost like there are many data sets and that shows biasness present in their created data sets. So these things also should be taken care while creating the data set. Like it should not just like it should not always flag or considered a post coming from a particular community as hate speech when it is truly not hate speech. Yeah, so to solve that problem, there is another work that has tried to like propose a training with adversarial loss kind of setting, so that this target community based bias can be reduced in the model. So in summary, what they did, like in their modeling pipeline, they introduced two parts. One is this like this label predictor, which basically tries to label the whether a particular post is hate speech or not. So that is basically the hate speech classification system. Apart from that, they have this another part in the model that is called this domain classifier or the target classifier. Its task is the post from which community it came actually, like who actually wrote this post, that domain classifier should not be able to tell. So it means it is like a target or community agnostic. So this is the summary of the modeling. So if your domain classifier is like community agnostic, it means like it is just considered each text as like equal. From which community it comes, it is not the it should not consider that. So this is the summary, and they have seen, okay, by doing this kind of modeling, they got a bit better performance. So basically also another way to solve this bias problem that they have, like in this paper, they have found out is, so the rationale thing I talked about. So when we train the model using the rationale, okay, this is why a particular post should be considered as hate speech, then the bias in the model has been dropped. So the model actually understands better like why this post is hate speech or it should be considered as hateful. So using rationalists also can make the model less biased, and this has been shown by this various metric. And we can see this BERT hate explain model where the rationalists have been used to train got better performance compared to the model where the rationale has not been passed through the model for predicting a post as hateful or not. Okay, so far the work that I have talked, so mostly it was only text detection or meme detection. However, the content that are being posted in the social media platforms are done by the users, and the users who are engaged in posting this hateful content called hateful users. So very less work have been done on this hateful user detection task, and this is one task where they tries to detect this hateful user, the users who are engaged in posting hateful content. So they basically tried several models, from this text-based model to only network-based model to semi-supervised graph neural network-based model. And they have seen like this semi-supervised based graph neural network model performed well, and they tried this thing on two platforms, Gab and Twitter. Like Gab is free speech platform and Twitter is moderated, and on both the platform, yeah, this semi-supervised algorithm performed well. So the basic idea of this model is modeling is like they not only consider the post that has been made by the users. Apart from that, they consider the network connection of the users, their follower and followee, because it has been seen earlier these hateful users are densely connected, therefore their network properties are also unique. So apart from the text that they made, their network properties also help to like understand whether a particular post is hateful, a particular user is hateful or not. In this kind of network, not all user has to be labeled. Like you can have some user labeled and some user unlabeled, and by using the whole network and then the text that they have post, this kind of classification model work, this graph say GCNN, AGNN. And yeah, overall it has been seen these textual and network features together improve the hateful user detection better. So however, we think like more work needs to be done on this area, because majority of the work just only focus on detecting individual level post. Yeah. So this is it related to the hate speech detection and how is their evaluation has. And now like we'll move forward with the mitigation part of hate speech. As we know, the only detecting hate speech, not everything. We should have now the mechanism how we can mitigate the hate speech that has posted on social media platform. And it is not the case we should only ban the post, the hateful post that has been made. So now I will hand over it to Punojay.
Again, we can take a small break if you have any questions in this part or any previous parts, and then move forward. Should we move on? Okay. The next part after detecting hate speech is so what to do after detecting hate speech. So that is one of the main crucial part. So there in the social media platforms, there has been different strategies like deletion of post, that is deleting some hateful post in the in social media platform, suspension of user account, and shadow banning. So shadow banning is the same as suspension of user account, but it is suspended for a very short time, let's say 24 hours. And after after that, it is again allowed, and the person is again allowed to tweet. This can be effective in case of very viral events where some of the users are temporarily blocked, and then again they are asked to they're again allowed to post. But in all of this, one important question that remains is whether banning is effective or not. Several of the studies have tried to understand this exact thing, that whether banning the particular post or the user is actually an effective solution to the hate speech problem. So in this study on Reddit, in 2015, Reddit closed actually several subreddits which were due to the violations of Reddit's anti-harassment policy. So this was a major event in Reddit, and two of the most affected communities were the subreddit Fat People Hate and Coontown. And this paper tries to understand if this ban was effective. Now to do this, they again tried to see which users were banned and what happened to them. So what they found was that most of these users who were banned actually left the Reddit platform, and and others who were present migrated to other subreddits where hate was prominent. And the second finding was on the community level, the migrant users did not bring additional hate speech with them to the new communities, nor did the long-time residents pick it up from them, which means that Reddit did not spread the infection. That means that migrant users who were bringing in, who were joining the new platform, new subreddits, did not actually cause any problems with did not spread the hate speech. So this is again shown using this graphs here. You can see that after the this event, that is the banning, the amount of hate speech has actually reduced quite drastically. But one important factor that we left was, what about the users who had left the Reddit platform? This paper tries to understand the same thing, that what happens if after the deplatforming, where the user goes and what happens to them. Do they remain hateful, or how their audience actually changes? So this study was also done on Reddit as well as Twitter, and they tried to study what happens when the users who get banned from Twitter joins Gap. They found that through both these figures. First one is of the toxicity, and the second is of the number of followers. So what they found was that both this group of users, like one who is leaving Twitter and then joining Gap, and the one who is leaving Reddit and then joining Gap, both have an increased level of toxicity in the newer platform as well. So that is shown using this graph. But one important point is that the audience that they can potentially reach actually decreases. So if you see the Gap versus Twitter follower count, you will see that in Twitter they have a large number of followers, whereas in Gap they have a slightly less followers. So their audience decreases, but their toxicity or the hatredness of their post does not. So this points to the fact that although banning can seem effective in short term in the same platform, it might not be effective if we consider the community as a whole. And hence we need better alternatives. Yes, sure. So they had they follow some of the popular people, I think. Then they built a classification algorithm so that they can measure that their type of post or who are they following. So these things are similar. So then they are marking the users as similar. Yeah, not just like they have some like follower counts after that they have done that. So it is not using the usernames, because usernames can be different in two platforms. So they have some algorithms to detect those users. Okay. So moving on to one of the alternatives, that is counter speech. So counter speech is an textual response that can directly intervene with the head content. So this is an example. So the first point is an hate speech, and the second user is trying to write a response. But if you carefully see, it is again responding using a hate speech itself. And the last two examples, one is by a machine and one is by a user, is actually trying to de-escalate the conversation. The first one is saying that using race and religion respectfully to attempt to prove a point is ridiculous and offensive. And the second is the language used is highly offensive and all ethnicities and social groups deserve tolerance. So both these statements actually show a way to counter the hate content, and this also tries to de-escalate the situation. Now, there are various ways to do counter speech, and 7 of them are noted here. This is based on a popular research study by Benish et al. In 2016, where they found out different types of counter speech as they scroll the social media platforms. So the first one is presenting of facts to correct misstatements or misperceptions. This is actually done quite often, that you can correct one of the arguments that the particular person is taking, and then repost that respond to them using that. The second one is pointing out hypocrisy or contradictions. In this, you can contradict one of the arguments. For example, if someone says that uh, some very false statement, you can contradict that using this hypocrisy or contradictions in their statement. Then another interesting category is affiliation. So this is where we are affiliating with either the target community or the one who is speaking. So in this example, a bit of context before that, the hate speech was about a guy, like a guy was speaking that gays should not be allowed in some temples or something. So they like churches. So he said that he is a Christian as well as a gay, and then why he thinks that this was wrong. So he starts the post with the affiliating with both the target as well as the speaker community, so that the person can understand that he is part of them and thereby can change his or her viewpoint. Another interesting category is like visual communication, where we use like memes or other types of photographs to do the same thing. There is still an like underrepresented part in this whole presentation, but you can see an example in this case that how we are not like blaming some extremist behavior to the entire community. Then we can have humor and sarcasm to do the same thing, that you can use humor to classify something as like to counter something. For example, one example can be that someone says that, okay, please join this movement to hate some community. You can say that, why, okay, I'm too busy in my own work or something. So there are various forms of this humor and sarcasm as well. Then we can also have denouncing of hateful or dangerous speech. So this is a very easy category because we are just trying to say that something is hateful and we should not write that. And finally, tone. So tone actually represents that we should always end or add some positive messages to the counter speech. For example, I love people, I treat everyone with respect. So these are two examples where the person is trying to create a positive environment of his post so that the hate speaker can change or at least get affected by this viewpoint. So these are all the types. Now there has been several NGOs that are trying to do this task of writing counter speech. Two of the popular of them are We Counter Hate and No Hate Speech Movement. So both this actually have a Twitter account where they regularly post something like a counter speech in once a while. So all in all, we saw that indeed counter speech has a potential value. But why is counter speech necessary? The first thing is that not all platforms allow moderation. So something like a Gab or a platform like Fortune does not allow for moderation, and there will exist such platforms because of the different viewpoints of the platform or the social media platforms. Hence, in these cases, counter speech can be one of the most important moderation policy, that the users can write counter speech in response to a hate speech so that their effect is reduced to some extent. In the moderated platforms as well, this counter speech can act as a first line of response before other intervention techniques takes place. So usually this banning, if the sentence or the hate speech is very complex, it requires several levels of decision making to arrive at a point whether to ban that person or not. But simply writing that, okay, do not speak something like this, can be easily done as a first line of response. But one problem is that it adds to challenges of content moderation. So the content moderation pipeline itself has several of the layers like detection and then filtering, then trying to decide what to do. And adding a generation part that the user has to write will further create more complexities. Hence, we want to see if we can use natural language generation models or NLGs to help the moderators. So this is a response generation problem in a nutshell, and where we pass something like hate speech to a transformer based or a generation model, and it generates a counter speech. So you can think it as a question answering system or an argument reply system. All the systems are similar, and they try to create a output given the hate speech. And here, two of the important challenges are building a quality and diverse data set and building the generation framework itself. Coming to the quality and diverse data set, we'll take a look at the current data sets that are available and try to understand what are the properties of them. So these are the current popular data sets that are available in this research space, and there are two categories broadly. One is collected from Reddit and Gab, and then they are annotated by crowd workers. And the second one is collected using synthetic methods that the users are themselves writing the hate speech, and then they are also writing the counter speech, and these are done mostly by expert annotators. So one of the problems of crowd workers is that they write very simple content. So that is the denouncing or denouncing the derogated category. As I said that don't say that slur words. But we have other counter speech categories which are slightly more effective. So the crowd workers, if not incentivized, they will not write such content. The second problem is in the second data set that the synthetic hate speech that the annotators are adding might be very simple and may not represent the complex nature of the hate speech present in the real world. And the third problem is that if we say that, okay, crowd workers are writing very simple counter speech, let us use expert annotators, but then we cannot scale the data set using only the expert annotators. So the challenge in this space is how to build a quality and diverse counter speech dataset at scale. So I will leave with these questions, and I will try to get back after some time when we did discuss reduction part or the generation part. And we will see how the current frameworks are actually trying to do that. But this is still an open problem in this area, and there are lots of research efforts required in the same. So now the second part, that building the generation framework. Here we are actually focusing on what can be the generation framework that can support such a system, that given the hate speech, we can generate the counters. There are several earlier methods of generation models like VAE-RNN, and there are other recent models like GPU2 architecture, which are mostly like transformers model. These are very popular now, as we already know with ChatGPT coming in. And we can use these models to actually train the pipeline and then generate counter speech. In this study, before moving forward, we need to understand how these models are actually performing given this task of counter speech generation. So what they did in this study, they took a data set, that is the expert-based data set, and then they tried to understand what is the difference, how do the different models perform given the same type of decoding architecture or like same type of generation architecture. And then they also compared different decoding methodologies like beam search, top P, top K, and combining both top P and top K. So they found that overall, so these all of these models are one or other form of a transformer model. And out of this dialog GPT, which is trained on a Reddit conversations dataset, it actually performs the best based on Rouge, Blue 1, Blue 3, as well as the toxicity scores. And it is much more comparable in terms of novelty as well. So overall, dialog GPT actually performs better in many of these cases. The second part is about the decoding methods. So one certain thing that they found was that beam search is repetitive. This is due to the fact that it tries to select the best output in terms of the decoding algorithm. and its novelty is pretty less. Whereas stochastic methods, which try to take in, which try to consider random sample when decoding, is actually better in terms of novelty. So in an applicable system, you have to look what do you actually prefer in that setting. If we have a annotator who can write very good counter speech, we may need the beam search system to write a very simple counter speech, and then the annotator can actually modify it. Whereas if we want to, where we have very novice annotators who might not be that much expert in this writing, we can use this stochastic methods so that the generated outputs are novel, and then the annotators can edit like grammatical problems. That is the part about building the generation framework. So we have discussed how these generation frameworks are like, how do you use the current generation models to fine tune on the counter speech datasets, but there are still space for improvements. The first step is how to improve the generation. So the second step is hallucination, and the third step is personalization. So I'll go one by one through each one of them. So one way to improve the generation can be to select a better counter speech. So there can be different counter speech that can be generated by this model, and we would like to select a counter speech which is better than the rest. So in this work, they do the same thing using a 3-stage pipeline, that is generate, prune, and select. And what they do is they use a candidate generation framework based on VARNN, and they use this framework because it was easy to use then. But now you can easily add any transformer-based models to this and do the same experiments. The next step is candidate pruning. Now, in this part, they are actually selecting the ones which are grammatically more sound. They are doing this using a grammatical classifier, and they are selecting the grammatical candidate pool. And the final step is response selection, where in this part, they are trying to select the responses which are actually more similar to the hate speech that is given. For example, the first one is more similar to this statement. Hence, they are using this as a prominent response. So doing that actually improved their generation part to quite a bit. As you can see, the blue has jumped like almost doubled. And so this can be an effective way to select the counter speech which are more relevant and more similar to the hate speech. And as you can see, their BM25 score, that is the relevance part, that is also improving a lot. So these are some of the generated counter speech from the generate, prune, select architecture. And as you can see, these are all very good in their nature. Okay, the second step is how to use what about hallucination? So what is hallucination? Let us look at an example. So if you see this example, it says that Muslims are invading our country, and there are different like 16 this many number of Muslims in the UK, and if you exclude the London, that is actually increasing by 2%, which does not seem very significant. So this entire counter speech is perfectly all right. If you see the nature of it, it is actually countering with the fact, and this can have an effect on the user. But one problem is that the official record for the Muslim population is just above 3 million, and the model is writing something else. Hence, this is not credible. Like the factual statements is not correct. So what to do? So in this paper, they actually tried a knowledge grounded technique to generate better counter speech. So in this paper, they first used the hate speech to select the queries. So queries can be phrases, noun phrases or normal phrases, which can be used to select the knowledge from a search engine. And they have a knowledge base created from some popular knowledge graphs. And then they try to use this query to select some of the knowledge sentences. And then they select these knowledge sentences based on their like top K relevance to the hate speech. And finally, they use this hate speech they use this hate speech as well as this knowledge sentence and then do the same counter speech generation. This generation is again similar to the previous ones that we saw with the normal transformer model. So they just concat hate speech and then knowledge sentences, and then they do the very same thing. So they find that this knowledge sentence is actually helping them in terms of the novelty. That is, the counter switch is becoming more novel than the normal architecture like GPU2, which is without any knowledge base. It is also helping them with the Bluetooth, that is the relevance score. With the ground truth, it is actually becoming more relevant. And finally, they also saw what how the knowledge overlap is, or the knowledge overlap with n-grams. So they checked with 1, 2, and 3 n-grams, and they saw that indeed the knowledge overlap is increasing. So that means the counter speech actually using the knowledge sentences quite well in their generation. And finally, personalization. So what is still lacking in the system? So we have improved the generation in terms of its relevancy, as well as we have tried to introduce knowledge so that the statement is credible. But still now we have not included any personalization, which can be helpful in case a moderator wants to write a certain type of counter speech. So what we can do simply is to use controller modules to make the framing of the counter speech better. So there is a lot of literature in terms of how control generation can take place. But before moving to that, we will actually try to understand if controlling the tone or controlling the counter speech is actually helpful or not. So in a very general research, they found that sentimental or casual tone is in response to a particular argument is actually receiving 83% more responses than the one without that. In terms of counter speech, Matthew et al. Found that different communities find different types of counter speech effective. We will talk about this in few slides later. And finally, empathy-based counter speech can help reduce the racist comments. These 3 studies actually show that indeed the type or the tone of counter speech can have an effect on the response from the user. So one easy strategy that can be used to add this control is to control the tone using writing counter speech by supervision. So as I discussed the knowledge sentence part, so we can use a similar tone label with the counter speech and then generate. But none of these data sets, as you can see here, these 3 does not have any such like type suggestions. So they have just the hate and counter speech. So we do not have the type information. So we cannot directly train these models. So what to do? So we can use something called Jedi models. So these Jedi models are smaller generation models that can be used to control the larger model, that is the counter speech generation model. Here, the counter speech generation model is used as it is. And then we use several of the Jedi models. Here in this paper, they only tried detoxification, politeness, and emotion. But this framework is general enough to include other types as well. And finally, there is an output token selector, which uses both these outputs, that is Jedi model output and the counter generation model output. And then finally selects a token which includes the controller outputs as well as the counter speech output, so that the overall output of the counter speech or the overall counter speech actually includes this following properties. So overall, they found with this using this attribute controller technique, they actually get a 15 to 18% and 6 to 8% boost in politeness and detoxification score respectively across all the data sets. If you look at these dialog GPT versus dialog GPT M control models, this is again done on the same 3 datasets that I showed earlier, and without even having any like tone or type information, we are able to use these Jedi models to train to better the control parameters. And the second is that using in the emotional attributes, joy has the highest score for control generation, which might be due to the fact that it is slightly easier to control in this setting. One particular problem that the authors thought about is about the fluency and relevancy. although they are decreasing a bit than the original pipelines, that is without any control, but more or less they are stable when the control is taking place. And finally, when they tested with multi-attribute setting, that is the setting where all three are present, that is one emotion, politeness, and detoxification, they actually saw that there are certain complementing attributes like joy plus polite plus detox, which can increase the individual performance as well. More research on these ideas can needs to be there so that we can understand how to control these models, and we can also try to understand what other types or controls we can like get in place instead of these things. Now, after these two discussions, I had again come to the point about how to collect the data better. Now we till now we have already found out that there can be this like how we can have already built a generation model with some data, and now you want to improve the collection strategy. What we can do is that we can use the task generation model, and that can be assigned as an author. Now, in general, this author is a human or annotator, and instead of that human annotator, we can use a model to generate the text, the counter speech. Where the human is actually employed is during the reviewing cycle. So this author is generating several counter speech. Now, making the author as a generation model is helpful because it can be scalable, and it can generate the things much faster than a human. And the human is actually using the reviewer part, where he can classify something as counter speech or not. So the human or a classifier model here, a classifier model can be used if we have enough data and like a good quality classifier model. We can filter the output accordingly. And finally, they have an additional step, that is post-editing phase, where the NGO operators looks over the entire data set. This is to ensure that the written counter speech is actually very much within the lines of the accepted counter speech. So the authors say that this framework is scalable, allowed to obtain data set that are suitable in terms of diversity, novelty, and quantity. But one thing that is in this method is that the author that is tasked with text generation should be at least having a decent performance in terms of counter generation. And we have to continuously improve this author so that we do not get repetitive examples. Based on this strategy, they have built two data sets. One is this singleton data set, which is having different target communities. But here also, one main thing is that the hate speech in both of these is again synthetic. That is one problem that I already said. And here they are using mostly expert annotators. So they are not again like using crowd annotators. But overall, they use this strategy to make the counter speech or the data sets much better than earlier. So now one important step in this whole part is how to review the counter speech. So here for single-turn datasets, they have several metrics like acceptance rate. That is the amount of how many of the counter speech that is written by the generation model is actually accepted. HTR, that is the error rate that the annotator has to correct. So if the annotator is correcting the particular counter speech, how many tokens he is correcting. Novelty, how much novel the generation is. Repetition rate, that is just the opposite of novelty. And then vocabulary expansion. This is again a type of novelty that whether the author is contributing the vocabulary or the reviewer is contributing. These are various strategies which we can know how the author is actually performing in terms of generation. And for multi-turn datasets, they additionally use turn deletion as well as turn swap. Turn deletion is if we are writing a chain of counter speech and hate speech, if we have to delete a turn because of the bad quality, that is turn deletion. And turn swap is if you have to like swap the two turns, that hate speech is written instead of counter speech and counter speech instead of hate speech. So that is turn swap. But all of these strategies are pseudo measurements technique to actually understand the quality of counter speech. So can we make something which can detect the quality directly? So that brings us to the problem of detection of counter speech or detection of a good quality counter speech. So this part is again having the same challenges. So first is a building of data set for counter speech generation, counter speech detection, and then the detection framework itself. Here also we will use some of the popular methods like transformers architecture because they are mostly good at classifying things. And the primary challenge is to build the data set for counter speech detection. There has been several works which are trying to do the same. So here in this data sets, in this data sets, there is a section of counter speech. That is, I have noted the number of counter speech in each of one of them, and the total data that is present. And the rest of data can be hate speech or non-counter speech text. And finally, we can build a classifier which can detect the particular text as counter speech or not. Again, we have to ensure that the counter speech that we are collecting is diverse enough so that we can detect good quality counter speech. And in one of these data sets, that is thou shall not hate, that has additionally the types information as well. And we can see, as I was saying, that different communities have different types of preferences. We see that these were again the data set were collected from comments of YouTube videos which were showing hate towards some communities. So some of the videos were showing hate towards Jews, some were towards blacks, and others were towards LGBTQ community. And here they see that denouncing a hateful or dangerous speech and positive tone is actually higher for Jews. For blacks, warning of offline or online consequences and denouncing is again higher. And for LGBTQ community, pointing out hypocrisy or contradiction and denouncing and humor is actually a very prominent counter speech strategy. One interesting part here, that what they found was the hostile part. So these are textual examples where the author or the user is actually countering, but the response itself is hostile. So this we do not recommend when we are training some counter speech detection pipeline, because that is not a recommended way of counter speech. If we see, so we saw that there is a difference in the number of counter speech per community and per type. We also can see the same thing using the likes. So we can see that the African American community actually likes to call out for racism and talk about consequences. If we compare the likes of these different types, and the likes for these two parts are actually higher. Similarly, for the Jewish community, we observe that the people affiliate with both the target and source community. And as you can see here, the affiliation has received a lot of likes other than the other parts. Then we are moving to the detection framework. So we have discussed the data sets that are present. And this is again a nascent research area. And we can see more diverse data set in this part in the coming years. So in the detection part, as we said, that it is very simple, that we have a post and then we can detect is a counter speech or not. And transformer models like BERT or Roberta can be used in this pipeline. We can also use something like parent of the post and then do the same thing. In this research, they actually did the same, and they found that if we use the parent, which can be used as an additional context, the counter speech, written counter speech, actually better in terms of the detection is actually better in terms of F1 score, precision, and recall. So all these parts are about how we can detect and generate counter speech. But one important question is counter speech an effective solution towards this mitigation part? So we have discussed that there are different mitigation strategies, and we saw that they were also not effective. So is counter speech effective or not? So before moving to the studies, we would first try to understand when do we call something as a successful counter speech. So this is when the speech has a favorable impact on the original hateful user, which can allow him to shift his or her discourse, if not his or her beliefs. And this is usually indicated by an apology or apology on this side. So this is an example of the same thing. that this particular user is actually trying to apply, say sorry for some of the past insensitive tweets that he had. And the second type of success is to positively affect the discourse norm. So usually it does not happen that the first step is very easy. It may require several back and forth between the user and the counter speaker. But the second type of the second type of effect is very important, so that we are not only affecting the user that is speaking the hate speech, but also the entire community. So these are all the users who are just cyber bystanders who read one or more of the relevant exchange of tweets. So this type of success is important because we want to not only stop the spread from the user that is posting hate speech, but also we do not want to spread the hate speech by other bystanders. To this end, there has been different recommended strategies and discussed strategies which can help in writing more successful counter speech. For example, the one in the left are actually recommended strategies for good counter speech, and on the right, these are discouraged strategies. Now, in the recommended strategies, we have warning of consequences, shaming and labeling, empathy and affiliation, humor, images. In the right side, we have hostile or aggressive tones that I already said. Fact checking, although it is quite done a lot of time, but directly fact checking may actually hamper the response rather than be helpful. So when we are writing fact checking arguments, we should add something like an empathy or affiliation so that the response is well received. And finally, we have harassment and silencing. This again creates the problem rather than solving it, because we are harassing the user that is posting, and this can again either make him blow out. So what are the evidence from social media platform about the effect or the effectiveness of counter speech? So in this study, they actually found that the counter hate messages can actually discourage users from turning hateful in the first place. So this shows the number of hate neighbor exposures. If you see the baseline versus the observed, it is actually increasing a lot as the hateful neighbor increases. And this is actually less when the counter hate neighbor exposure increases, and it is actually less than the baseline that they have observed. So the risk of becoming hateful is actually reducing if we have more number of counter hate neighbors. Secondly, another study suggests that organized hate speech is associated with the changes in public discourse, and that counter speech, especially when it is organized, may be helpful in curbing the hateful rhetoric in online discourse. So what they see here is that there are two events. One is RG, one is RI. So these are the starting points of the hateful event or the hateful organized hate speech campaigns. And this is the starting point of organized counter speech campaign. And if you see after this point, which is the counter speech campaign, the number of likes for counter speech is actually increasing, whereas the number of likes for hate speech is actually decreasing. So if the counter speech is also organized by organization members, where different members are actually taking turns to counter hate, it can actually have an effect. Similarly, the discussion length of both these things like counter and hate speech is actually becoming same as we move towards after the event of RI. So both these things suggest that counter speech can be effective when it is especially when it is organized. So this is about general effectiveness of general counter speech. Now we can also say that whether type of counter speech matters or not. I have written one point in the starting slides that empathy can have more effect, but also affiliation, where they use control accounts to sanction the harassers. So they have different settings. So they have a mapping, 2x2 mapping about high follower and low follower, and white male and black male. So they use this in then they create 4 such bots, that is high follower white male, high follower black male, and then they try to see if we write the same counter speech, what is the effect, just based on the affiliation of the particular user. So they see that if we have high follower white male writing against a racist slur, they have significantly reduced that use of slur in the online platform. Another study compares warning of consequences, humor, and empathy, and tries to see the effects of these three parts. So the first finding is that empathy-based counter speech actually increases the retrospective deletion of xenophobic hate speech. So uh, once the hate speech is posted, after that the counter speech is posted, and they found that empathy-based counter speech actually increase the retrospective deletion. That is, they delete this post, the earlier post, when they see this empathetic counter speech, which is marked by this blue bar. And the second finding is that the prospective creation of xenophobic hate speech over a 4-week follow-up period actually reduce. That is again shown using this blue bar. As you can see, the green and the red bars are quite towards the right side, and this is towards the left side, which shows that it is quite less. So these are all the parts that we cover in this mitigation of hate speech. So we mainly discussed how the earlier mitigation strategies are working, like banning, and then we shifted our focus on entirely on counter speech and how if the counter speech is getting effective or not through different studies. And we also discussed about the counter speech detection as well as generation and how we can improve the systems. Now we will look into, so for anyone who is joining this like research area, we have prepared SWOT analysis where they can understand the strength, weakness, opportunity, threats in this area. And this can help them in starting out in this research area. So what are the strengths? There is an advancement in the NLP pipelines. That is, we have been introduced to transformers, which are very capable of detecting very complex tasks. And this has also shown that in hate speech literature, this has a large role to play. Then we have multilingual endeavors in the hate speech area, that different authors or researchers are trying to detect multilingual hate speech, which is again important because most of the research earlier was focused on English language, which is very like narrow area. And then we have NGO initiatives which are doing the same, like they are helping the authors in some cases, as we have pointed out in the dataset creations. They are helping out the authors in creating better datasets, as well as launching their own campaigns to deter hate speech. We have now multiple datasets having different either rationals or targets, which really is a very good part of this entire research area, that we do not have a lack of datasets as some other areas. There has been themes, research grants given based on this research area a lot because it is so socially relevant. What are the weaknesses? So the one primary weakness is inconsistent annotations or subjective annotations. And this is an area which we still need to work on, because since there are different definitions of hate speech that is given by different platforms, we have different types of annotations, that we cannot merge the datasets, or one model which is working on some dataset does not actually work on our dataset with different annotations. We have a lot of diverse tasks which seem similar, but are actually very different. For example, hate speech and fear speech, as I've seen in this tutorial. There is a lack of generalizability, as we say. One is due to the inconsistent annotations. Others are due to the contextual change through the time. So if you train a model in 2016, it will not work in the current landscape. There is bias in the data, bias in terms of annotators, keyword-based bias or topic-based bias, as well as it is again amplified by the models itself. And finally, all these models do not have explainability. So because explainability is a crucial criteria in this space, because we are directly dealing with the online world or the users directly. So explainable models are the need of the hour, but we do not have that currently. Opportunities are multimodal datasets. So these are datasets that are currently coming up. Image-based counter hate speech or counter speech, video-based datasets, audio-based datasets, all are coming up. And this opens up an opportunity for a lot of research in this area, as we are going more multimodal in terms of our communication as far as goes, multimodal data sets or multimodal hate speech detection will be crucial in the coming stages. User is a very important aspect, but again, this is very underrated in terms of research. So we need more such um, studies based on how you can use the user information or the network characteristics to again detect hate speech. And given the type or the changing nature of hate speech, this can be an important area to work on. There are new variants coming up, which each can be a particular research area like fear speech or dangerous speech. And finally, we have a lot of things to develop in the last part, that is the counter speech as a mitigation strategy. And there also we can improve the models of generation or detection of counter speech as well as find out newer mitigation strategies, which can be helpful in the long run. Finally, the threats that we have in this research area, that is, first of all, it is always a battle between users and detection. So once we have a detection pipeline online, users will try to write something very subtle that can pass the detection or do not get detected in this area. So this was done in 2016, I guess, where some common terms like Google or was being used instead of the slur words, and the filtering algorithms at the time or even now may not detect such conditions. There has been alternative platforms which are coming up like Gab, where the collection of data set as well as these detection algorithms, applying these detection algorithms might be difficult. There are government agencies which are weaponizing hate speech for their own agenda. And finally, there are laws which are used to silence dissent, which are all hampering the research area as a whole. Finally, we'd like to talk about the different campaigns that are currently there, which are actively trying to create better models as well as initiatives which can help us in solving this problem of hate speech. And finally, we have set up a lot of resources for your help. There is a Notion page which contains a list of hate speech papers starting from 2016 or 15, when this research area actually was started or was increasing at a good pace, and till now. And we can check the research papers which are selected by us. And then we have demo codes for using our open source models. I will try to see if I can run some of them if I have some time. And finally, we have a dataset resource created and maintained by Leon and Bertie. This is the same resource that we talked about earlier, where you can search the datasets, where you can use the datasets to do your detection algorithm or counter speech generation, etc. And finally, we have a resource collected for all the teachers and young people, because they are also an important part in curbing this hateful or hatred in social media as well as offline. So if you can teach them to be more empathetic or kind towards other, this problem will actually be kind of nipped in the bud. Finally, thank you. And you can contact us for later for questions, and we will be available for any questioning later.